So a student of mine found this old test online for review, and it's all old diploma questions, and asked me if I'd do a key. So I thought I could do it on here. So the first question has to do with endothermic reactions, and going through it, hopefully we know A is not true because endothermic would not be, oh, there's that beeping there, would not be negative. Energy is a reactant, not a product. Temperature of the surroundings would decrease, not increase. So then just that last one, it is your answer, but just to understand why, same products have greater potential energy than the reactants. If you drew a quick potential energy diagram, reactants are lower than your products. So that's why that one is true. Looking at number 2, we have the delta H of the forward reaction, which is given, where delta H, if you took it out, would be endothermic, and it would be that positive 100. If you reverse the reaction, we know we have to change the sign. So the delta H would still be the same value, but it would be negative. So the answer for this one would be D. Looking at number 1 from the numerical response, asking about 1 mole for the heat of formation of benzene. You're just looking at page 4 or 5 of your data booklet, and you would see that 1 mole is 49.1, and it's a positive value, kilojoules per mole. So this is already representing 1 mole, so we're just writing in 49.1. For number 2, we have mercury thermometer, tells you how much mercury you have. We have the temperature change and the specific heat capacity. Because this is just heating and cooling a substance, that substance is mercury. This is just an MC delta T question. So we would have that 1.02 grams multiplied by that specific heat capacity given, and joules per gram degree Celsius, and then multiply that by that temperature change. So we'll have final minus initial, so -13 minus -38. So we plug that into our calculator, and you'll see that your value you get here is 3.57. Moving on from here, this next page, looking at question 3, we have a combustion reaction, and we have some energy in there, and it's just asking what type of reaction this is. So the fact that you have a hydrocarbon in the presence of oxygen getting out carbon dioxide and water, that is definitely showing you combustion. This next one is pretty wordy, and I did find it hard to kind of figure out exactly what it's asking. But it's telling you that the production of limestone can happen if you roast crushed limestone in a kiln. So you have that CaCO3, and we're heating it up. And when you do, you produce limestone, which is CaO, and carbon dioxide. Now, with this, it's actually Hess's law short, where we know that delta H of the reaction is the sum of the products minus the reactants. So from page 4 or 5, we would get the value for CaCO3, CaO, and carbon dioxide. Your products total is negative 1,028.4 kilojoules, and then you're going to subtract your reactants total. And again, I'm getting these values and adding them in terms of the sum from page 4 or 5 of my data booklet. And then when I do this correctly, I should see that my answer is C. Now, moving on from there, asking about the production of our lime. With this, because you're getting out that positive value, it is an endothermic reaction. And because it's a chemical reaction, it's a chemical change. So this answer is D. If it was a phase change, we would actually be just going from a solid to a liquid or a liquid to a gas, or vice versa. Looking at this next one about photosynthesis, if anything is undergoing photosynthesis, doesn't matter what it is, it's going to be an endothermic reaction. And when you are endothermic, you do have an increase in potential energy. So this is A, but just to, again, have that understanding, endothermic looks like that. Your potential energy is started lower and ends higher. So that is going to be the increase. Question number 7, asking which one is most stable. This has to do with thermal stability, and that's your ability to resist decomposition. So if we know all of the formations, we can just change the sign, and all of these would be positive. And then your most positive is the most stable. So the answer here would be A. Number 8, asking about which fossil fuel was the sun or the original energy source. Well, the sun is the original source of all energy, but going through this, the only one that is a fossil fuel is H. So you're looking for some sort of hydrocarbon, and we had methane there. Now, the last question on this page has to do with the formula NH equals delta H. And sorry, that's my delta sign. This pen is just kind of strange. So if I'm forming 1 mole of propane, I would take that 0.100 moles. And if it's formation, I will just get that value for propane from my data booklet. So negative 393.5 kilojoules per 1 mole. Moles cancel, plug that in, and you'll see your answer is 39.4 kilojoules. So the amount of energy released if 0.1 react. Now, question number 9 has to do with a catalyst or activation energy. So we do see the activation energy, right? We have reactants to the top of the hill. And when you add in a catalyst, it just lowers your activation energy. So when it's asking about the broken line, that would be your catalyst. Now, number 10 could be a little bit tricky because it's not telling you what the compound is, but it is giving you the weight and the molar mass. So based on that, you have enough information to get to moles. And then we have that information about water. So you can tell that this is calorimetry. I'm just going to go over here so I have more room. So you'll have NH equals negative MC delta T. This side about the reaction has to do with compound X. So you're starting with your 300 grams, multiplying it by the molar mass in a way that the moles can cancel. And that was 75.0 grams, just getting that from the question. We're solving for H. And then the right-hand side is about the water. So you have the 1,000 grams of water. You have the specific heat capacity of water. And you also have the temperature change, which is 3 degrees. So when we're done, we just want to remember the value you get here is based on specific heat capacities units. So it will be in joules. So take it and divide it by 1,000 so you can get to kilojoules. And if you do it correctly, you should see your answer is A. Number 11 here is another Hess's Law short. So you just look at page 4 or 5. Write down each of these heats of formation. So this one, this would just be 0, and this one. And then we want to get the total of your products, subtract your reactants. And if we do this one correctly, we should see that your answer is A. Now, the next one, again, just being able to read a potential energy diagram. And in this case, your heat of the reaction is always from your reactants to your products. So we're looking for this distance. And based on what we're seeing here, the other part, we can tell that the distance is 80, but all endothermic graphs will have this shape. So then we want to pick C to show that it's endothermic. Moving on to number 13. This is just showing the difference between endo and exo. So that first reaction, you have your enthalpy on the reactant side. That would be endothermic. The second one on the product side, that is exothermic. And then 3 is negative, that is exothermic. And the last one is not. So here your answer was D. Okay. This is just showing one of those theory questions. Again, can give you a bunch of information, but always original source of energy is the sun. And with number 15 asking about when propane is burned, now you're doing Hess's Law short once again. This question, though, you just have to remember that if you do have a coefficient in front of the compound, just multiply your heats of formation by that number. And then you're still doing the same thing. Delta H will equal the sum of the products minus the reactants. And I'm just coming here for that. And your answer here should be D. Number 4 carries on from that previous information. And now it's asking about the heat released. Heat released is always an NH equals delta H question. So first we want to turn our 449 grams into moles by getting 1 mole of propane, which equals 44.11 grams. Then you want to multiply it by the delta H of the reaction. And the delta H of this reaction is what's calculated in number 15. So I'm going to go ahead and fill that in. Negative 2,043.9 kilojoules. And this is per 1 mole because only 1 mole is being combusted in this reaction. Now, you are technically done here, but we can just do one more step because it is asking for megajoules. And at this point, we are left with kilojoules. So if we multiply by 1 megajoule over 1,000 kilojoules, because there's, sorry, I'm writing grams here, but these are joules, because there's 1,000 kilojoules in 1 megajoule, then you'll see that last one cancel. You can plug that all in, and you should see the answer is 20.8. Now, number 16 is a theory question showing that we know the difference between combustion and cellular respiration. So A, looks like it's going to be true because combustion is exothermic and respiration is endothermic. So not just looks like, this is your answer, but just going through the rest, we see why B is wrong because saying respiration is exothermic. C is saying respiration requires the presence of light. That would be photosynthesis, so that's not true. And D, both produce carbon dioxide. That's not true. One produces it, one uses it as a reactant. So going on from here to number 17. 17 is essentially another theory question. So if you're taking a look at this, I don't have the equation. So the equation above had K plus 1/2 of Br, give it Br2 to give you KBr. So just recognizing that this is a formation reaction and the delta H of this value is negative 393.8 kilojoules per mole. So with this one, the first one, A, talking about the phase change, this is not a phase change, this is a chemical reaction. B, dissolving KBr is exothermic. Well, this doesn't tell us that, so that could be true, but I'm not sure. C, the decomposition is endothermic. That is going to be our answer, and that's because if this forward reaction formation gives you a negative value, if you reverse the reaction, you would change your sign, and reversing the reaction would show you decomposition. And then the last one, talking about stability, well, that's something else we can't interpret based on this question. Looking at number 18, this is a theory question. So we have 100 mils of the acid with 200 mils of the base reacting. How this changed is that the acid got doubled and the value of, or the amount of the base got doubled. Now, if we're doubling everything, your temperature released will be more, and that should double as well. But in terms of your molar enthalpy, if you look at kilojoules per mole, that is per 1 mole reacting. So that does not change. That's mole ratios. That's going to be the change, same every time. So the answer here is going to be C. Your heat will double because we've doubled everything, but the molar heat of the reaction, figuring out for 1 mole, that's going to stay the same. This next one, when you're reading it over, we have this information of hydrogen peroxide, how it decomposes slowly into water and oxygen. And maybe some of you have seen this experiment in other chemistry courses. Often it's called elephant's toothpaste because you get this big amount of gas coming out. Anyway, not the point. But what it is telling you is that you're adding in a small amount of MnO2, right? 0.010 grams. And then this is all going to happen. The reaction takes place and temperature increases. But at the end, you have the same amount of that MnO2. So because this wasn't used up in the reaction, but it did cause the reaction to happen, that means that is a catalyst. Okay. Looking at number 20, asking about coal and that it's mainly composed of carbon. If we want to look at the complete combustion of carbon, now this is a word you want to concentrate on, complete. If it's complete combustion, you're not going to get any side products like carbon monoxide. If it's combustion, we know we're going to give off heat. So the answer here is going to be B because it's exothermic and we're getting carbon dioxide. So we're not going to choose the ones that's making carbon monoxide because that would be incomplete combustion. Now this not the last one, but number 21 here, asking about coal being burned to form SO2. If you do take a look at this one, you would have the formula S8 and you would add in your O2 and your forming SO2. And if you go to balance this, we'll need a few 8s. If you look up your delta H value, again, it would only represent 1 mole. So to do that, we can divide everything by 8. So we'll have 1 over 8 S8 plus O2 to give you just 1 mole of SO2. Now the delta H value of negative 296.8 reflects the reaction because this is kilojoules per 1 mole being formed. So that's what this part is here. So because it's exothermic, you can rule out these two, and then you want to see which one makes more sense in terms of values, and that would be A when you're looking at your y-axis. Almost finishing up here, 2 more pages to go. So we have a reaction, and then it's asking about the energy change for just methane. And in that one, when we're looking at the reaction, this value is representing 3 moles of methane. So if you want to represent 1 mole of methane, you'll have to divide that value by 3. And because it is exothermic, you would still have your energy written on the product side, because that is what would show an exothermic reaction. Number 23 is another Q equals MC delta T question, but in this one you want to solve for your specific heat capacity. So you were given your energy in joules, you were given the mass in grams, we want C, and you have your temperature change. So we're just isolating C by dividing the other parts over, and you'll see that your answer is also C once again. This last one about cold packs is if you're going to use this cold pack, and if we know anything about a cold pack, is that it is going to get cold. So when that happens, that means energy is going into this, which means your surroundings get cold. So when we're looking at this, it's endothermic, and it would result in a decrease in temperature. So your answer is C. Okay. Looking over this, I said 2 more pages, but it was 3. So looking over this one, I did find this question a little bit confusing when I started, because it's giving you the heat capacity of the calorimeter and water, and kind of combining it. We can't do our normal NH equals negative MC delta T because of this C value being combined with water and the calorimeter. The other part you want to notice is that for your specific heat capacity, it's just joules per degree Celsius. So we don't even have any mass involved. So we don't need any grams, which means we don't need mass to cancel. So we don't need this M value at all. So because it is asking molar enthalpy of the hydrochloric acid, we're still going to use the hydrochloric acid to get to moles. So starting with 0.05, right, we're going to turn our milliliters into liters. Multiply this by your concentration. So you get liters to cancel. We're solving for H. And then on the right-hand side, you get negative that specific heat capacity, so 228 joules per degree Celsius, times your temperature change, which was your final 16.4 minus initial, which is 21.6, so negative 5.2 degrees Celsius. So you'll see that when you solve for H, moles will also cancel. Moles don't cancel. Your degrees also cancel, and you will be left with kilojoules per mole. So just getting H alone. Because it's an endothermic reaction, we know that because their temperature is dropping. This first value is positive, so you'd give it a 1. And then once you solve for H, you'd get 474. This one definitely made me think, and it took me a while, but I think the hint here is really focusing on the specific heat capacity and the fact that it did not split water and the calorimeter, but gave it to you together. With number 25, because we're mixing an acid and a base together, this would be a neutralization reaction, so just theory. And moving on to number 6, having this chemical reaction and then asking about the energy quantity of energy available if 1 gram reacts. This would be your NH equals delta H question, where we want to figure out the energy released. So starting with N, you have 1 gram of, I believe it was sucrose reacting. So you'll have to multiply this by the molar mass of sucrose, which is 342.34. Then you need to multiply this by the energy of the reaction. So negative 5640.3 kilojoules. And this value represents just 1 mole reacting, so divided by 1 mole. And when we plug this in, you'll get your answer, which is 16.5. All right. Oh, my last page didn't come up. There was one more page, but I guess we'll stop here since I don't have it right now. Like always, if you did find this helpful, please make sure to subscribe. And if there's any other video I can do for you, just let me know. Thank you for watching.